Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam free online classes. How are you all? Nice? Very happy. You are all bubbling with enthusiasm, right? Sit only for half an hour, okay? Are you ready with books and pens? Okay. So we are coming to a very interesting chapter called Exponents and Powers. And let us just recall what we have seen in the previous class. Meaning of exponents and its applications. For example, if you have a number like 2 and if you want to multiply, say 2 into 2 into 2, see 4 times you are multiplying, right? So this can be simply written as 2 to the power of 5. Here 2 is called the base number and 5 is called the exponent. 5 is called the exponent. Okay. So this is called base and this is called exponent. Exponent means the power to which the given number is raised. And what the advantage? It can simplify the terms. Is it not? So instead of writing into like that, we can shortly write like this. And for example, distance between sun and the earth. Okay, it's a very big number, huge number. That can be written in the standard form. Or radius of the earth. Or distance between sun and the Saturn. All different planets' distances. All these can be written in a very short way by the help of exponents. Okay. And also, expressing large numbers in the standard form. Suppose you have a number like say 1496. It can be written in the standard form. Standard form means numbers should be written from 1 to 10 and others should be written in the form of say 1.496 into 10 to the power of 3. That is called standard form. So 1 to 10 means single digits. Then other digits should be expressed in the powers of 10. Correct? And if you have a decimal also, it can be like that. Suppose you have 0.0005. How to write in standard form? That is 5 into, come on, 10 to the power of how many places? 1, 2, 3, 4, minus 4. That is called as standard form. So that is another advantage of the exponents. Okay. And also we have seen with the powers with negative exponents. For example, you can have like this 5 to the power of 4. That is negative exponent. What is the value of this? This is 1 by 5 to the power of 4. Okay. Suppose you have 10 to the power of minus 3. How do you write it? 1 by 10 cube. Correct? So in general, if you have e to the power of minus m, nothing but 1 by e to the power of m. So these minus m, minus 3, minus 4, etc. are called negative exponents. Okay? And also we have seen about writing the numbers in expanded form. Suppose you have say 2345. How do you write in expanded form? See, 5 is called unit place, correct? So 5 is unit place. So 5 into 1. What is the 1? 10 to the power of 0. Then after unit place come tens place. So in tens place 4 into 10 to the power of 1. You have studied in the primary classes. Correct? Then you have 3. 10 to the power of 2. 100th place. Then you have 1000th place. 2 into 10 to the power of 3. So this is what is called as expanded form. All in powers of 10. Why you must take 10 only? It is easy for calculation. Is it not? And it is easy for writing also. So these are the things we have seen in the previous class. Now shall we see the home assignment? Yeah, first question. Find the multiplicative inverse of 10 to the power of minus 5. Multiplicative inverse is 1 by 10 to the power of 5. We have the formula a to the power of minus m is equal to 1 by a to the power of m. That is called multiplicative inverse. Here a should not be 0. M can be 0, but a should not be 0. So it is a non-zero integer. And then you have 5 to the power of minus 3. It can be written as 1 by 5 cube. So 1 by 5 cube is the multiplicative inverse of 5 to the power of minus 3. And 10 to the power of minus 100. Come on. Who will tell? Yeah, you will tell? Okay. Write down in your book there. 1 by 10 to the power of 100. So whatever minus is there, it will be plus when you bring it to denominator. Followed? Okay. Now coming to today's topic. Expand. No, one more question. Expand the following numbers using exponents. So this is the second question. Let us expand using exponents. Just now I was telling about that. So this is one by one we'll do 1025.63. That is the first question. Come on. It has 2 decimal places. Is it not? And this is unit place, tens place, 100 place, 1000 place. So it starts with 1000. What is 10,000 means what? 10 to the power of 3. They are telling write in exponents. And then 0 into 10 square. Then you have 2 into 10 to the power of 1. And 5 into 10 to the power of 0. Correct? So units place, tens place, 100 place, 1000 place. Okay? Then come to decimals. How to write decimals? You must write minus 1. First decimal. Lastly, second decimal. 10 to the power of minus 2. Correct? That's all. Come into second one. You can do yourself. Okay, here only changes. You have got one more decimal place. Again, this is 1000 place, right? So 1 into 1000, that is 10 cube. 2 into 100, 10 square. 5 into 10, 10 to the power of 1. Then 6 into 1, that 10 to the power of 0. Anything to the power of 0 is 1. Is it not? That is also one of the laws. Coming to first decimal, you have 2. 2 into 10 to the power of minus 1. Then you have 4. 10 to the power of minus 2. Lastly, you have 9, 10 to the power of minus 3. All should be in same line. So, in case of decimals, you must write 10 to the power of minus 1 first decimal, 10 to the power minus 2 second decimal, third decimal. Understood? Okay, this is the answer for that question. Now we will pass on to, you note it down, today's topic. Today's topic is just continuation of what you have learnt. So, you have got laws of experiments. You already seen in your previous class. Just for understanding, a to the power of m into. So, we learned that for any non-zero integer a, non-zero integer means maybe to 1 or 2 or 3 like that, but not 0. So, where m and n are natural numbers, does this law of exponents are negative? Let us explore. So, what about negatives? Does this law hold good? Hold good, that you must add. If the exponents are negative. Positive, you can give one example. For example, you have 10 to the power of 2 into 10 to the power of say 5. Here what is A? A is 10. What is M? M is 2. Here base must be same, that is important. So, 10 to the power of 2 plus 5 it comes. So, 10 to the power of 7. Now, the question is, these are all positive values. Similarly, you can take base 2, base 3, base 4 like that. But both of these A should be same. Now, coming to negatives. So, here minus 3, base is negative here, and even the exponents also negative. Will the law hold good? We will see. So, here what happens? Minus 3 to the power of minus 4 means the multiplicative inverse of this is minus 3 to the power of plus 4. Minus 4 when it comes to denominator become plus 4. Similarly, here minus 3 to the power of minus 3 means minus 3 cube. So, that minus become plus. Now, if you add these powers, because you are multiplying you have minus 3 is the base, and then the powers are 4 plus 3, 7. So, here minus 1 by minus 3 to the power of 7 is here. When you take it to numerator, that becomes minus 7. You know law, we have studied one law yesterday, previous class. A to the power of minus m is equal to 1 by a to the power of m. Here 1 by minus 3 to the power of 7 is there. So, when you make it to the numerator, it becomes minus. Correct? So, it was here minus 1 by 3 to the power of 7 was there, and when it bring to numerator, it will be minus 3 to the power of minus 7. Correct? So, plus 7 become minus 7. Note that. Okay. Then second example, minus 5 to the power of minus 4, minus 5 square. You can read it as minus 5 square or 5 to the power of 2. Both are same. So, here let us put this first. Minus 5 square into 1 by 5 to the minus 5 to the power of 4. This will be equal to, come on, what's your right? You have minus 5 square numerator divided by minus 5 to the power of 4. Here you can use the formula a to the power of m by a to the power of n is equal to a to the power of m minus n. or you can bring it to new denominator here. This is brought to new denominator here. So plus 2 become minus 2, this as it is. So you have minus 1 by minus 5 to the power of 4 minus 2. That is 1 by 4 minus 5 to the power of 4 minus 2 is plus 2 here. Bring it to numerator, becomes minus 2. Or you are using formula here directly. There is one formula one we are going to see next. There is one formula here, a to the power of m by a to the power of n is equal to a to the power of m minus n. That formula is there. You have seen in the last year, previous year. So that also you can use. So you have minus 5 to the power of 2 by minus 5 to the power of 4. This can be written as minus 5 to the power of m minus n, 2 minus 4. So it is easy. So you have minus 5 to the power of minus 2, very simple, by using the second law of exponents. Or you can do like this also, there is nothing wrong. But you must know clearly, plus becomes minus. Okay, anyway you can do. So what does it show? It shows that even if the exponents are negative, this law holds good. Followed? That's what you have to see, important. Now we will see some more problems. Now, when a and b are non-zero integers, non-zero means what? It may be 1 or 2 or 3 or 9, anywhere. Integers, but not 10. 10 is called number. 1 to 9 they are called as integer, 0 to 9. After 10 we call it as numbers. So m and n are any integers. We can verify other laws of exponents. So first and foremost law. What is the condition? Condition is a should be non-zero and m and n should be integers. Means you should not take fraction. Say like this. Suppose you have 5 to the power of half by 5 to the power of 1 by 4. This is not there. Only integers you must take. Okay. And this is the first law. Second law says a to the power of m to the power of n is equal to a to the power of mn. So for example, I will give one example here. Say suppose you have 5 to the power of 6 by 5 to the power of 4. What is the answer? Come on. Answer will be 5 to the power of 6 minus 4, that is 5 to the power of 2, that is 25. But here base must be same. Here 5 you have taken base. Same. Coming to this, suppose you have 2 cube to the power of 5. M is 3 there, n is 5. So 2 to the power of, come on, 3 5s are. The 2 to the power of 15 is the answer. To the power of 15, okay, like that is the meaning. And third law, a to the power of m into a to the power of b to the power of m is equal to ab to the power of m. All this you have studied earlier. Suppose you have 4 to the power of 2 into 3 to the power of 2 is equal to 4 3s are 12 to the power of 2. That is the meaning. Okay. So AB means what? 4 3s are 12. And coming to this, just now I was telling about that. Suppose you have 3 to the power of 5 and here 3 to the power of say 2. 3 to the power of 5 minus 2. 3 to the power of 3, that is 27. M minus n, that is 5 minus 2, that is 3. Followed? So these are the laws you have studied earlier. Here again and again you must know this m and n should be integers, and this is a should be a non-zero, a and b should be non-zero integers. Okay, that's the laws we have seen in the previous class. Now we will work out some problems on this using that class. Simplify 3 to the power of 7 by 3 to the power of 4. What is the law? Then and there write the law. A to the power of m by a to the power of n. Come on. What do you write? A to the power of? Yes. M minus n. What is a here? A is 3. M is 7 minus 4. 3 to the power of 3, that is 27. Correct? Coming to this, a to the power of 4 by a to the power of 2 means a to the power of 4 minus 2, that is a square. 4 minus 2 is square. You can verify it also. What is a to the power of 4? How many times a? 4 times. Denominator you have a 2 times. So these 2 cancels. What remains? A square remains. Correct? And third one, 2 to the power of 5 by 2 to the power of minus 6. So 2 to the power of 5 by 2 to the power of 6. The minus 6, when you bring it down, it becomes plus 6. So 2 to the power of 5 minus 6. 2 to the power of minus 1. What do you mean 2 to the power of minus 1? 1 by 2. Correct? 1 by 2. 2 to the power of minus 1 means here to, this formula is there, no? What is the formula here? A to the power of minus m is equal to 1 by a to the power of m. And this is a to the power of m by a to the power of n is equal to a to the power of m minus n. Okay? And now, note it down. Express 4 to the power of minus 3 as a power with base 2. So 4 to the power of minus 3 is given. What do you mean 4 to the power of minus 3? This is 1 by 4 cube, correct? Because we know the formula, a to the power of minus m is equal to 1 by a to the power of m. This you must practice 10 times, all the laws of exponents. Okay. Now what is 4 cube? 4 is 2 into 2 cube. Correct? 2 to the 4. So you can write it as 2 to the power of minus 3 into 2 to the power of minus 3. You can write. Because you are asked to write in the form of base 2. This is the base 2. Correct? For example, this is 2 cube is 8. 8 into 8 is 64. So 1 by 4 cube is also 64. So both are correct. So this is how you write in the powers of base 2. Okay? And now we'll pass on next problem. Simplify and write the answer in the exponential form. So answer must be in the exponential form, means you must write the powers. So we know the formula. Then and there write formulas. What is the formula? a to the power of m by a to the power of m, n is equal to a to the power of m minus n, one formula. Second formula, all these formulas also will get value. Second one is a to the power of m to the power of n is equal to a to the power of mn. And third formula is a to the power of minus m is equal to 1 by a to the power of m. Understood? That you have to apply here now. Now this is 2 to the power of 5 by 2 cube to the power of 5. And then this is 1 by 2 to the power of 5. Okay. So this is 5 5s are 25. 2 to the power of 5 5s are 25. And this is 2 to the power 25. And this is 5 3s are 15. 15 into 2 to the power of 5. So a you can write in a simple way. We'll do like this. A to the power of m by a to the power of n is equal to a to the power of m minus n, correct? So you can write it as 5 minus 3 to the power of 5. What is 5 minus 3? 2 to the power of 2 to the power of 5 into 2 to the power of 5. So you have these 2 to the power of 10 it becomes. 2 5s are. A to the power of m to the power of n. So 2 5s are 10. 1 by 2 to the power of 5. Both base are same. So you can also write it as 2 to the power of 10 by 2 to the power of 5. So write it as 10 minus 5. Law, this law. 10 minus 5 is how much? That is the answer. So simple, short and sweet, and its value is 2 multiplied by 5 times. It will be 32. 2 to the 4 to the 8, 16, 32. 2 5s are 2 into 2 into 2 into 2. 5 times it becomes 32. So not correctly. What you have done first? This 2 to the power of 5 by 2 to the power of 3 we did, and other remains as it is. This is third law, this we have taken, and here m minus n, 5 minus 3 to the power of 5. 5 minus 3 is 2 to the power of 5, 1 by 2 to the power of 5. So 2 5s are 10 by 1 by 2 to the power of 5. So that will be equal to 10 minus 5, that is 5. Answer is 32. Okay, understood? Noted? Very nice. Shall we pass on to home assignment? Home assignment, first question. Simplify and express the result in power notation. Means exponents with positive exponent. Minus 4 to the power of 5 divided by minus 4 to the power of 8. This is 1 by 2 cube square. Second one, 1 by 3 to the power of minus 2. Second one is 1 by 2 cube to the square. Third one, 1 by 3 to the power of minus 2. Fourth one, 2 to the power of minus 5 by 2 to the power of minus 6. Fifth one, minus 4 to the power of 5 into minus 4 to the power of 10. Okay. Then we will see Swami's quotation. Be good, do good, see good. This is the way to God. This is what Bhagwan Baba says. So come prepared with the answers to home assignment. Thank you.